This is another video on factoring because factoring is very important in helping you to simplify and solve equations or expressions. So let's look at two more factoring techniques. Up first is looking at the sum and difference of cubes. So we're looking at expressions that have a cubed minus b cubed or a cubed plus b cubed. And both of these patterns are very similar. Notice in the first factor, you have your a term, what you're cubing on the left side, and the second part of the first factor is your b term, what you're cubing on the right side, and then the other factor has an a squared, an ab, and a b squared. And here's a cute trick to remember those signs. All you have to remember is the word SOAP, S-O-A-P. First sign is always the same. Notice here, it's x cubed, a difference of cubes. We have a difference here for our first factor. If it's a sum of cubes, we have a plus sign for our first factor. Up next, the next sign is always the opposite. Right? Here are our opposite signs, right? So when it's a difference, it's the opposite sign. When it's the sum, it's a subtraction sign. And then finally, always positive, right? The last signs are positive for both of them. So you can just remember a, b, then the other factor is a squared, ab, b squared, and you can use your SOAP, same, opposite, and always positive, to help you fill in those sign values. So try the first one out. You're going to want to figure out what the a and the b is, and then figure out what the expression will be. So pause the video and try solving 27x cubed minus 125. Did you figure out that a is the cube of that, or 3x, and b is the cube of 125, or 5? So here we have a cubed minus b cubed, so we're going to have 3x minus 5, because we're going to keep the sign. Then we're going to have 3x squared, and then the opposite of our sign, so it'll be positive, and then multiply the two together, 15x, and then the last one is always positive, and that's going to be your b squared, which would be 25. And we could rewrite this as 3x minus 5 and 9x squared plus 15x plus 25. The pen does not want to work today. The other technique I wanted to talk about is factor by grouping, and you'll be happy to know we've already done that when we were doing factoring trinomials that have a leading coefficient other than 1. Remember, we took that middle term and broke it up into two different terms and then used factor by grouping. So you're going to do the same thing here in terms of grouping terms together. So group the first two terms together and the second two terms together, and now look for a common factor in each of those terms. So what's the common factor, or GCF, in 3x cubed minus x squared? And hopefully you came up with x squared, and then we'd be left with a 3x minus 1, and in our second grouping we could factor out a 2, and we're left with 3x minus 1. And again, the only way this grouping works is if when you factor out those first terms, you get the same two factors. Again, notice 3x minus 1, 3x minus 1. The grouping technique will work here if that is what you end up with. If you end up with two different terms, grouping will not work. So now, what can we factor out? That 3x minus 1, and I'm left with an x squared plus 2. And then always look to see if you can factor anything further, and in this case we can't. So overall, to summarize factoring, what are things that you should do, right? So when you're trying to factor, the first thing you should look for, right, is to factor something out. You're looking for that greatest common factor. If you can factor anything out of all of your terms, do that first. Next, you have different techniques depending on what you have, right? If we have a trinomial, you can try all the different techniques we used for that, depending if it had a coefficient of 1 or a coefficient other than 1. Then beyond your basic trinomial, you can try things like today where we looked at grouping. And again, remember, if you're using grouping, that common factor must appear, or things with special patterns, right? Your difference of squares or difference of cubes, right? Those are all great techniques to think about when you're trying to factor. So now let's try some problems and think about how we're going to approach factoring them. So up first we have 128x to the fourth plus 16x. Remember to think, can I find that greatest common factor first? Right, so you might be thinking, well, 8x I could factor out, and then I'd be left with 16x cubed plus 2, right? But always stop yourself and ask, did I factor out everything? Right, and hopefully here you can see, oh, wait a minute, I actually could have factored out another 2, so really, if you factor, it could have been 16x, right? We're factoring out that other 2, and we'd be left with 8x cubed plus 1. And now, can we still ask ourselves, is there anything more we can do? Well, hopefully you notice this. This is a perfect cube, and that's a perfect cube. Right here, A could equal 2x, and B could equal 1 as your perfect cubes. 2x plus 1. And then our a squared, in this case, we're going to use the opposite side, ab plus b squared. And don't forget our SOAP, same, opposite, and always positive. And if we tack on our 16x out front, we can simplify this into 16x times 2x plus 1, and then times 4x all squared minus 2x plus 1. Now let's try some more examples. Feel free to pause the video and try factoring yourself first, and then come back and look for the solution. So for problem 4, did you first try to factor out 2? And you'll be left with t to the fourth plus 16t squared plus 64. Now we need to factor this trinomial. Hopefully you recognize it as a form of a t squared, but we're going to go ahead and let p equal t squared. Then we can rewrite this trinomial using p's, right? Our t to the fourth, if p is equal to t squared, will equal p squared, plus 16 t squared is p, plus 64. We still have that 2 up front. Now this is a little more manageable to factor. Right now we've got just a coefficient of 1 quadratic equation, and this will factor into p plus 8 times p plus 8. And don't forget the 2 out front. But we're not done. Don't forget we need to substitute back in terms of t. So this would be equal to t times, what was p? It's t squared plus 8 times t squared plus 8. That works for 2 times t squared plus 8, and that's all squared. So let's look at number 5. Remember again, our first goal is to factor out any common terms. So let's look at the left side and the right side. Both of them have y's, and both of them have y plus 2's. So let's look at the y's first. What's the least amount of y that we can factor out? And hopefully you're thinking y to the fourth. Now let's look at those y plus 2's. I've got 3 of them here, and I've got 4 of them here. So the least amount I can factor out is y plus 2 to the third. Now let's see what we have left. If we factor out y to the fourth, y plus 2 cubed out of the first term, I'm going to take everything out, but it doesn't leave me with 0, it leaves me with 1. Now if we look at the second term, if I factor out y to the 4, I'll still have 1y left, and my y plus 2's, I will also have one of those left. We can simplify this a little bit more by combining terms here. I'll have a 1 plus a y squared plus a 2y. And if we rearrange that, surprise, surprise, we have a trinomial here that can factor into y plus 1 squared. And don't forget about our original factors out here, our y to the fourth and our y plus 2 to the third. Just a few more problems to go through. Let me bring this on up. All right, looking at number 6. Hopefully, again, our first step, can we factor anything out? And hopefully you can see that x minus y appears in both terms. And that's going to leave us with an a squared minus a b squared. And now we can factor more that right side right here. That's a difference of squares. So we can actually factor this into a minus b and a plus, not a y, sorry, a b. And finally, let's look at number 7 here. This one, hopefully you recognize, is different in that it has 4 terms, not 3 terms, and it's not a quadratic to start, right? It's actually a cubic. So we're going to have to use one of our other methods to try factoring this. And grouping will work perfectly, right? So I'm going to group this into 2 parts, and now let's try factoring, and hopefully we'll get that common factor. Right, so in that first set there, what can I factor out? I could factor out a 9 and an x squared, and that will leave me with x and then plus 2. All right, now in the second set here, I could factor out a negative 1. Right, so I'm going to factor out a negative 1 right from that sign right there, and I'll be left with an x, yay, 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 plus 2 as well. So now I know I can continue factoring this. So both of these have the x plus 2 in common, and then that'll leave us with 9x squared minus 1, and we can actually factor that 9x squared minus 1 a little bit further. So I'm going to write my x plus 2, and then my 9x squared I'm going to factor into 3x plus 1 and 3x minus 1, as it is a difference of squares. So hopefully this factoring review helped a little more. Try answering the WISC, and I will see you in class real soon.